In these notes, we're going to learn how to solve equations that involve fractions. So that's why it says solve rational equations. We're going to break this up into 2 lessons. So this is going to be part 1. So please make sure you have your heading on here. What we want to do is whenever we're solving an equation with fractions, we want to try to get rid of all the fractions first. So that's going to be our goal for both notes. So we're just going to start off with a little sentence here. So when solving fractional equations, and that's the same as rational. That's why I'm using this word here, so you know it's the same. Try to get rid of all of the fractions. Once you do that, it makes it much easier to solve an equation. So we're going to talk today about 2 different types of equations that would have fractions in it. One is where we would have 2 fractions on both sides, and we would use cross multiplication. So I want you to write cross multiplication. So you would use this method when you have 2 fractions that are equal to each other. So can you put after this, when 2 ratios, and that just means fractions. So I'm going to put fractions in parentheses. So when 2 ratios are equal. And you always want to make sure that when your answer is done, that your answer wouldn't make it undefined, meaning you don't want the denominator equaling 0. So I'm just going to put a little tiny note underneath this. Make sure answers do not make the fractions. Undefined. And what that means is the denominator is going to equal 0. So I'm just going to put in parentheses, denominator, I abbreviated that, denominator equals 0. Because if you ever get an answer where the denominator equals 0, it won't work. So we're just going to do one quick example of cross multiplying. So here's example A. Can you write, we're going to have 2 fractions equal to each other. So the first fraction is going to be x plus 1 over 2 minus x. The second fraction is going to be 2 over x minus 6. So x plus 1 over 2 minus x, if that was said wrong, and then on the other side, 2 over x minus 6. Because the only thing you have is 2 fractions equal to each other, we can cross multiply. So we're going to multiply those 2, and then we're going to multiply these 2 and set them equal to each other. So our equation is going to look like this. We're going to have these 2 in parentheses, so x plus 1 times x minus 6. That's going to be one side of your equation. On the other side is going to be your other loop. So we're going to multiply 2 by 2 minus x. Right then, we've gotten rid of our fractions. So that's what cross multiplying is about. Now, in order to do this, we need to get rid of all the parentheses. Here I would do the boxes. So if I would do the boxes, I'm going to simplify it just because of the time. If we did the boxes, this would become x squared. We would get minus 5x minus 6. And you can always pause it to do it on your own if you want. On the other side, if we distribute, we would get 2 times 2 is 4. 2 times negative x is minus 2x. Because we have a power of 2, we want to get it equal to 0. So we're going to move both of these terms to the left side. So I'm going to move this 2x over by adding 2x, and I'll put it underneath the 5x. I'm going to move this 4 over by subtracting 4 and putting it underneath the 6. If I do that, my 4's and my 2x's cancel out, and my new equation becomes x squared. This becomes minus 3x. This becomes minus 10, and we have equals 0. Now, because we have a power of 2 to solve this, we can factor. So there's no GCF, so I'm going to start off with my 2 sets of parentheses. Don't forget equals 0 at the end. I put x and x in the front. Factors of 10 that subtract to give me 3 would be 5 and 2. We want a negative 3, so that would be 2 minus 5. So the 2 is positive, minus 5 means the 5 is negative. Now, since we have two things being multiplied equal to 0, we're going to set them both equal to 0. So I'm going to give them both two equations. We have x minus 5 equals 0, and we have x plus 2 equals 0. Now we solve them both. So I'm going to add 5 to both sides. We get x equals 5. I'm not going to circle it yet, just in case. Over here, I'm going to subtract 2 from both sides. My 2's cancel out, and I get x equals negative 2. I'm not going to circle it yet. I want to go back to my original equation, and I want to plug these in to make sure the bottom doesn't equal 0, because if it does, it won't be the answer. So if I plug in 5 here, 2 minus 5, that's negative 3, so that's okay. We don't want 0. 5 minus 6 is negative 1. That's okay. So there's one of our answers. Over here, if I plug in a negative 2, 2 minus negative 2, that's 4. If it was 2, then it wouldn't work. Negative 2 minus 6 is negative 8. That doesn't give us 0, so we're okay, as long as we don't get 0 on the bottom. Now we're going to talk about another way if we have some fractions, many of them, not just 2 equal to each other. So now we're going to talk about this thing called the LCD that we're going to get rid of. So I'm going to switch to the next paper. The other method is we're going to multiply by the LCD. So can you write LCD for me? That stands for least common denominator. So what we would do is we would multiply both sides of the equation. Multiply both sides of the equation by the LCD. And by both sides, I mean every single term. So I'm going to put in parentheses all terms, because you're going to see that I'm going to be distributing in a second. We also want to make sure that our answers don't give us any undefined or answers that don't work. So I'm going to have you write one little note here. Make sure to check for extraneous roots. And extraneous is spelled extra, and then E-N-E-O-U-S, roots. That means answers that you plug in that will not work, like being undefined. So we're going to do 2 of these kind of examples, and then we're done. So here's example B. So I'm going to have you write the equation, then we're going to separate it just so there's more room. So the equation is, we have a fraction, x minus 4 over 6, plus another fraction, x minus 2 over 10, and then equals another fraction, 31 over 15. We cannot cross multiply on this because we do not have just 2 fractions equal to each other. We have 3 fractions in our equation. So what we're going to do is we're going to find the LCD, and then we're going to multiply everything by that LCD. So I'm looking at my denominators. I have a 6, a 10, and a 15. I'm trying to think of the smallest multiple that they share in common. So what I'm going to do is I'm going to start with my biggest number, 15, and find multiples of that. And once I find a multiple that they share, I stop. So 15, 30, well, 30, I can take 6 and divide it into 30, and 10 I can divide into 30. So my LCD is going to be 30. So I'm going to put that on the side. So what you're doing is finding a multiple that they all share. It doesn't have to be the smallest, but it's easiest to be the smallest. So what I'm going to do and have you do is I'm going to take this and space it out so I have more room around it, because it's going to get crowded. So I'm going to put x minus 4 over 6, have some space, x minus 2 over 10, have some space, and then 31 over 15. So I'm spacing this out because it's going to get messy. Now what we do is we multiply everything by 30, every single term. So I'm going to multiply this by 30, and I'll put it over 1 since it's a fraction. I have to multiply this by 30, and I can't forget about this term. So every single one of them I put multiplying by 30 over 1. If I did it right, it's going to cancel out all my denominators. So now I'm going to look at each one separately. To simplify this, I say to myself, how many times does 6 go into 30? Well, 5 times. So I get to cross this out and change the 30 to a 5. So if you notice now, we have a 5 multiplied by an x minus 4. So notice that I put the x minus 4 in parentheses because I'm going to have to multiply everything by 5. Now I'll go over here. I'm going to bring down my plus sign. How many times does 10 go into 30? 3 times. So I get to cross off the 10, and I'm going to change the 30 to a 3. That means I'm going to multiply 3 by x minus 2, and notice I put it in parentheses. Now I move over here. I have an equals. 15 goes into 30 twice, so I can cross off my 15 and make the 30 a 2. So I'm going to multiply 31 times 2. I don't need parentheses because there's only 2 terms. Notice by multiplying by the LCD, I no longer have any fractions, and it makes it so much easier to solve. So now I'm going to go ahead and distribute. So 5 times x is 5x. 5 times negative 4 is negative 20. I come over here. 3 times x is a positive 3x. 3 times negative 2 is negative 6. Over here, 31 times 2 is 62. Next step, I can combine like terms. If I combine my x's, 5 and 3 is 8, so we have 8x. Negative 20 minus 6, I keep the signs with it, that would be negative 26, so minus 26. And now I have equals 62. Since I have my letter over here, there's no power of 2. I'm going to move this to the right, so I'm going to add 26 to both sides. 26 is cancel. So I bring down my 8x. 62 plus 26 is 88, so I have equals 88. Last step, I can divide both sides by 8. 8's cancel out. 88 divided by 8 is 11, so I have x equals 11. Before I circle, I'm going to look at my original example. I don't have any variables on the bottom, so if I was to plug in the 11 for x, it would only change the top, which I don't care about. So this answer is okay. So I'm going to go ahead and circle that. One more example. So example C. Here we're going to have 4 fractions. So example C, last one. So we're going to have 1 over 10 minus 1 over x equals 1 over 5x minus 2 over x squared. All right, so since I have multiple fractions, I cannot cross multiply. I need to find the LCD. My LCD is what I need my denominator to be in order to cancel it out. So I'm going to look at my numbers first. I have a 10 and a 5. Well, a multiple that they share in common would be 10, so I can use 10. You can use 20, you can use 30, but the smallest would be easiest. If you look at your x's, I see x squared as the highest x. So I'm going to need to also put an x squared as my LCD because we need to cancel out our x's, and the only way to do that is to multiply by the highest x we see, which is x squared. So now what I'm going to do is space this out, and I'm going to multiply everything by my LCD 10x squared. And if we do it right, our denominators will cancel. So I'm just going to bring this down and just put more spacing in between each term, just so when I multiply, it doesn't get too messy. So I just rewrote the exact equation all over again. Now what we're going to do is we're going to multiply by the LCD, 10x squared. So I'm going to give every single one of these fractions a 10x squared over 1 right next to it. And make sure you put your multiplication sign. So every single term, I'm going to put times 10x squared over 1. Times 10x squared over 1. Times 10x squared over 1. So every single term must get that LCD. And your LCD is what you need to cancel out the bottom. So now we're going to see what happens. If I look over here, we have a 10 on the top and the 10 on the bottom, so I get to cross those out. So I have an x squared times a 1. So you can write x squared times 1, or you can just write x squared if you can do that in your head. Over here, I'm going to bring down my minus sign. I have an x on the bottom and an x squared on the top, so I can cross this x out and change this x squared to an x since there was one more on the top. So now if you look, we have a 10x times a 1. You can skip this step and just write minus 10x because 10x times 1 is just 10x. Moving over here, bring down my equal sign. If I'm dividing, well, 5 goes into 10 2 times, so I'm going to cross off the 5 and change the 10 to a 2. There's one more x on the top and the bottom, so I get rid of the bottom x and change x squared to x. So notice now I have 2x times a 1. So 2x times 1 is 2x, so you can just skip and write 2x if you'd like. Moving over here, bring down the minus sign. If you look, we have an x squared on the top and an x squared on the bottom, so I get to cross those out because they cancel. I'm left with just 10 times 2. Well, you can skip that step. 10 times 2 is 20. So there's our new equation. So this is what we have. And of course, you could skip this little step since we're just multiplying most of these by 1. Now, if we solve this, because we have a power of 2, like the first example, we need to move everything to the left side. So I'm going to subtract 2x from both sides. I'll put that under here. And I'm going to add 20 to both sides. And I'll put that over here since I can't combine it. If I do that, my 2x's and my 20's cancel. My new equation, I bring down the x squared. Negative 10 minus 2 is negative 12x. I have a plus 20. And don't forget equals 0. Well, since there's a power of 2, I want to factor. There's no GCF, so I can go for 2 sets of parentheses. Don't forget equals 0. X and x go in the front. I need factors of 20 that add up to 12. That would be 10 and 2. 10 and 2. Since I'm adding, they need to be the same sign, and I want a negative 12, so they both need to be negatives. Next part, I can split these apart into 2 equations. So I have x minus 10 equals 0, and x minus 2 equals 0. Now I can go ahead and solve. This says minus 10, so I can add 10 to both sides. We get x equals 10. I'm going to hold off before I circle. Over here I see minus 2, so I'm going to add 2. 2's cancel. We have x equals 2. I'm going to make sure that these work, so I'm going to go up to the top and make sure when I plug these in, I won't get a 0 on the bottom. So if I plug in a 10 here, that doesn't give me 0. 5 times 10, that's 50, not 0. 10 squared is 100, not 0. Same thing with this 2. If I plug in a 2, I don't get a 0. So they are both answers. You'll notice in the next lesson, we are going to get answers that won't work, and you'll see as we check them. Please don't forget to submit your notes into Canvas to get credit for your work.